Alright, 3.1.
Never mind.
Derivatives of a function Alright, so a derivative, we say that the derivative of a function f with respect to the variable x is the function f prime whose value at x is f prime of x equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So hopefully that looks familiar. Provided the limit exists.
Is that F apostrophe?
Yeah, it means the derivative, but yes.
Okay.
Provided the limit exists. If f prime of x exists, we say f has a derivative, okay, or we can say is differentiable at x, and if a function is differentiable at every point in its domain, it is a differentiable function. What?
If it's differentiable.
Basically that you have a function and you can take its derivative. Like it'll make more sense once you see like an example of it. It's actually really easy. Well, I think we do the really easy stuff in this section. Now they start with the limit ones first. Okay, yeah, some of the easy stuff is in this section. Some of it we use the definition of a derivative, which is this.
Okay.
But that just depends on what you're given to start with. A derivative at a point the derivative of a function f at point x equals a is the limit of f prime of a equal to the limit as x approaches a of f of x minus f of a all over x minus a, provided the limit exists. What?
I think I broke this thing.
What is that?
Okay, clearly she needs to take anatomy.
Yeah, that's why I admit it.
Not your butt bone, it's your, like,
It's this bone.
That's what I thought.
Right.
And the moldy shirt you were talking about yesterday. So cute.
What does it
They're
say?
looking at each other.
It says Mike. Guess what day it is? It's mole day, and then on the back it says how happy are. I can't remember. It says something about how happy are DBCS students on mole day, and then it's like happier than 6.02 times 10 to the 23rd times
Whatever.
a mole, like as a mole on mole day or something like that. I can't remember exactly what it says, but something like that. It's really cute. It has little construction moles on it.
Is this the updated one?
Yeah, at the end of the game yesterday, I knew where the ball was going, so I stayed up, and I went to chest trap it, but instead of like cushioning it, I threw myself out there, and it like just smacked my chest, knocked the wind out of me, which is why I couldn't follow the ball up, but like knocked the wind out of me, and then ever since then I haven't been able to breathe properly.
That's probably should get that looked at.
Thank you.
Yeah, like certain movements hurt, and exhaling really hurts, talking hurts.
Oh, so then you can be quiet.
No, that's the problem.
All right, ways to denote derivatives.
Ridiculous.
Okay, so these are just I can't spell. Ways to write them. We can write it as y prime. We can write it as dy over dx. Can write it as df over dx. Or we can write it as d over dx of f of x. Okay. The ones that we typically will use are the y prime and the dy dx. Okay, so that's just telling you take the derivative of the function with respect to x, basically. So I'll write here just kind of how it's said. So this one is y prime. This one is dy dx. Okay, or the derivative of y with respect to x. Df dx, or the derivative of f with respect to with respect to x. In the last one, d dx of f at x. How that one is said, or the derivative of f at x. Okay, so those are all notations that we can use, but the ones that are starred are the ones that I will most commonly use or say. Alright, so then the last kind of definition type thing, we have one-sided limits. Or sorry, one-sided derivatives. We've done one-sided limits. So y is equal to f of x is differentiable on a closed interval a to b if it has a derivative at every interior point of the interval if the limits, and there's going to be two of them, the limit as h approaches 0 from the right of f of a plus h minus f of a all over h, and the limit as h approaches 0 from the left of f of a plus h minus, or well actually this should be b not a because it's going to be a different number. Well, it could be a different number. B plus h minus f of b all over h exists at the endpoints I'm going to start examples in just a second.
I'm ready. The limits are,
Like there.
yes.
I don't want to start examples without you because you'll get confused. I really want these nails to like fall off, but they just won't.
Honestly, really surprised they haven't.
Same. My nails like stick like really good. Like if things are only supposed to last like a week, they'll last like 3 or 4. These were supposed to last 3 and they're now at 4, so now they're just irritating.
Yeah, it is.
This is reasonable.
Are you excited for our meeting?
Sure.
Oh, can I like leave like literally just 2 minutes early so I ordered lunch? That way I'm not back in like.
I packed.
I have to heat up my food, but it should only take like a minute.
So do I. Well, I'm guessing Miss Patton will need some microwave probably.
One of the two of them will, yeah.
Okay,
All right, so the first one say to use the definition that says that f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So you're going to be given a value of a for the function, and then just like what we did last chapter with plugging stuff in, essentially you now are just using a instead of t or x or whatever the value
Is
was.
that H to N
Where?
under the limit?
This is h.
The
Down here?
Yes.
H to 0.
Let me see what I got.
Alright, so the first one, number 2.
Do you see what I
Word?
said? No, like literally half of the zero is broken. Well,
Why was that so magical?
because the zero wasn't there and then there was zero all of a sudden.
Okay, so while you get your sternum checked out, maybe your head too.
How
Did you have a head
You
injury?
clicked something and the zero just appeared out of nowhere.
I turned the light off.
Oh. Was the light just blocking the zero?
Hold on, this one's supposed to be x squared plus 4, not 2. For a equal to 1.
How's that supposed to be done?
So just like we did last chapter, we're gonna plug in a plus h, okay, with a being 1, okay, anywhere we see x, and then we're gonna do a anywhere we see an x, and then all over h, and then we're gonna cancel stuff out to find our limit. So the limit as h approaches 0 of 1 plus h squared plus 4 minus, let's see, 1 plus 4, so 5, all over h. So I'm going to factor this into 1 plus 2h plus h squared, and then 4 minus 5 is 1, or negative 1, all over h. So 1's cancel, leaving you with 2h plus h squared over h. You can pull out an h, so h times 2 plus h all over h. And remember, we have the limit as h approaches 0. So h cancels top and bottom, leaving you with the limit as h approaches 0 of 2 plus h, and that's just going to be equal to 2. So the derivative at that point is equal to 2. Now, there is a significantly easier way to do these problems, but these specifically say to use this definition here. So on a quiz or a test, if I tell you to use the definition, you have to use whatever definition I tell you to use. Okay, otherwise you can use the easier method that we'll get to in a little bit. All right, number 4. F of x is equal to x cubed plus x for a equal to 0. Okay, so we're using that same definition for this one. So the limit as h approaches 0 of, now it's going to be 0 plus h, so I can just write h cubed plus h minus, at 0, it's just 0 all over h.
Wait.
Hold on a second.
Yeah. What I got the last.
Yeah.
So you put in.
Well, so obviously we can ignore that. So I can pull an h out of the top. So the limit as h approaches 0 of h times h squared plus 1 all over h. H's cancel, leaving you with the limit as h approaches 0 of h squared plus 1. So h is going to 0, meaning I'm left with just 1. Alright, for the next ones, they say to use the definition.
Yeah.
They use the other one, f prime of a is equal to the limit as x approaches a of f of x minus f of a all over x minus a. So now we just leave the first one as is, okay, and then the second one we put in a, and then on the bottom we just do x minus whatever the a value is. So number 6, we have f of x is equal to x squared plus 4, and a is equal to 1. So you'll notice that's the same problem from number 2. So we're just going to verify that both definitions essentially give you the same answer. So the limit as x approaches a is 1, so as x approaches 1, we leave it as f of x initially, so x squared plus 4 minus, we're going to plug in 1 for x, so 1 plus 4 all over x minus 1.
That's just, oh, because, never mind. Because the limit is x to a. So since the first one just f of x, that's just what it is.
Yeah, so you just copy it down the first time. So I've got on top x squared. Okay, this is 5 there, so 4 minus 5 is negative 1. So x squared minus 1 over x minus 1. Well, if I plug in 1 as it is right now, I get a 0 on the bottom, and I can't have that, so I need to factor the top and see if I can cancel something. So x squared minus 1 is x plus 1, x minus 1, all over x minus 1. So my x minus 1's cancel. So the limit as x approaches 1 of x plus 1 is equal to 1 plus 1 is 2. So we got the same answer that we got for number 2. Okay, so I personally think this definition's a little easier. So if I just tell you to use the definition of a derivative, you can use either one. If I tell you specifically which one you have to use, then obviously you got to use that one. Okay, but I did tell you that there's an easier way to do derivatives without the definition. Okay, the definition just pretty much guarantees that you can get it at a point. But they won't always give you a point. Sometimes they just want you to find the derivative. And so if that's the case, there's an easier way to do it. So number 10, it says find dy dx if y is equal to 7x. So we're taking the derivative of y, okay, our function, with respect to x. So what power currently is on x? Okay, obviously we don't normally write that, but just for the sake of seeing what happens, I'm putting it there. If I tell you to take the derivative, what you do is whatever the exponent is here, you multiply it by the number in front. So that's just 7. And then you take the exponent that's here and you subtract 1. So in this case, that would be x to the 0, which is just 1. So the derivative, so dy dx is equal to 7. Which is significantly easier than what we just did with the definition.
So you said you take the coefficient divided by the exponent,
Multiply by the exponent.
multiply by the exponent,
And then subtract 1 from the exponent. So if you had like so if this was instead 7x cubed, dy dx would be equal to 3 times 7, so 21. And then you subtract 1 from the exponent, So that would be your derivative of that one. So it's actually really, really easy. It's probably one of the easiest things we'll do all year. It's just getting used to doing the multiplication and then the subtraction, stuff like that is just a little bit of an adjustment. So find, and again, they're just using different notations, but they all mean the same thing. d dx of f of x if f of x is equal to 3x squared. So what would I do for this one then?
Well, you get 9. Oh no, you multiply it. It'd be 6. 6x.
So 6x, because we multiply 2 times 3 gives you 6, and then subtract 1 from the exponent, so dy dx. And I pretty much will always switch to this notation, okay, as opposed to whatever they write, but it all means the same thing. So if you like one of them better, you can just write it as that one. Okay, I'm going to go back and revisit. I'm going to modify, okay, number 4. So we had f of x is equal to x cubed plus x, okay? So if I told you just to find dy dx for this, okay? Now, there's technically just a 1 in front of these, right? There's not any other numbers. So what you would do is you would just throw the number out front. So you'd have 3, and then that would be x squared plus, there's just a 1 here, so that's just going to end up being 1, because then you have 1 minus 1 is 0, so it's just x to the 1, or x to the 0, which is 1. So this would be the derivative here, okay? But this particular problem asks for it at a is equal to 0. So if we were to plug in 0, you'd have 3 times 0 squared plus 1 is just equal to 1. And so that's another way you could have also found the same thing that you did for the definition in that particular one. Okay, it's just another way you could have written it. Any questions about this? Okay. I'm going to give you guys just a couple of problems, and then tomorrow we're going to look at a little bit more with this section and then be done with it. So we might actually start 3.2 tomorrow as well. There's just like one more thing that we kind of need to do with it, but I want to let y'all get used to this part first before we do it. So do, let's see, 3, 5, 7, 9, and 11.